Okay, so for today we'll start with the very beginning part of the chapter 2, right? So actually last week we already in the previous video we actually discussed the very last part of chapter 2 already. So for today we are going back to the front, okay, so to learn all the important concept about chapter 2. Okay, so chapter 2 we talk about linear combination of random variable. So the word linear combination is the important one. You need to know what is the meaning for linear combination. Right, so we'll discuss this later. And then for this whole chapter, generally you need to know a few things here. Okay, so let's have a look for the learning outcome 2.1. Okay, so what you need to do is that you need to use some concept to solve the problem. Okay, so what are the concept that you need to do is you need to know the how to find out the expected value for ax plus b, how to find out the expected value for ax plus by, and also how the variance for ax plus by. Okay, then you have to use all the concept here to solve the problem. All right, and then besides knowing how to use the mean and variance to solve the problem, okay, and you need to also know that we focus on a field distribution here. Okay, so generally we will focus more on normal distribution. Okay, and also Poisson. So for the Poisson part, we learned it in the previous video already, in the last video. Okay, so for Poisson, right, we only focus on the variable x plus y. It can be 2x plus 3y or any other thing, but it is always restricted to x plus y only. Okay, because x plus y only will give you the same mean and same variance for Poisson. So we have done this part, okay, last week, all right, or in the last video. Okay, so for today's lesson, we are going to focus on how to use all the concepts to find out the mean and also the variance, okay, then apply in a normal distribution. Okay, and then what is the meaning of linear combination? So linear combination generally, okay, is what you seen here, right? So when we say ax plus b, you are having x power 1, right? It's linear, therefore we call it as linear combination. So like for this one, ax plus by, okay, both of x and y are also linear, right? Power 1. Therefore, we call them as linear combination. That means that you add them together or you minus together. So we as linear combination. Yeah. All right. So let's start with our main idea here. Okay, main thing. All right. So when we talk about random variable x, right? So from statistic 1, okay, you should know that the mean we write as ex, and then the variance we write as variance x. Okay. So if you form a new random variable ax plus b, so ax plus b, again, as what I said just now, x is power 1. Therefore, a and b are numbers. So when we're having ax plus b, this is linear combination. Okay, is known as a linear function or linear combination. All right, so as an example, all the value with power 1, all the variable with power 1. So we call it as linear function or linear combination. So as an example, 5x plus 1 is also a linear function, okay, or linear combination. Half x 7, 6 minus 2x, 4x, and so on. All right, so you'll see that all the similarity here is all the x are power 1. Therefore, we call it as linear. All right, okay. So when you want to find the linear variable x, okay, let us talk about the mean and also let us talk about the variance. Okay, so I give you some example here to understand how we actually try to get the mean and variance here. Okay, all right. So first, let's talk about this. Okay, given, let's say I give you a value, mean of x is equals to 5. Okay, then if I want you to find out the mean of 3. Okay, so this is the first rule that you need to know. When you are having the mean of 3, it is always equals to the number. Mean of x is 5. All right, so the mean of 3 is 3. These two is not related to each other. All right, so when you're having a mean of a number, then you will get that number. So e negative 5 is equals to negative 5. Okay, so now if let's say I want to use ex equals to 5 in my calculation, you will use it when they want you to find out the value like this. If they want you to find out E3x. Okay, so when you want to find the E3x, generally you need to take out the 3 from the E, and then you take 3 multiply with EX. So what is 3 multiply with EX? You are having 3 times 5, and therefore it is 15. Okay, so now there's one important result here, which is this one, which means when you are having A is any value, okay, or any value that you have is equals to the value that you have. Okay, and then when you are having 3x equals to 3EX, that means you pull out the 3, right? The general formula will be EAX equals to AEX, which is this one in our notes. Okay, so this is a formula for a basic linear function when you want to find the mean, and this is one of the examples that I show it to you to roughly know how we apply it. Okay, all right. Then how about if let's say they want you to calculate the mean, let's say for E. Okay, let's say E 2x minus 5. Okay, so if you want to get E 2x minus 5, you can separate it, become E 2x minus E5 first. Okay, and after that, you pull out the E, you pull out the 2, and then you're having 2EX minus 5, because E5 is similar with this concept, right? So you should get the 5. So you have 2 times EX and minus 5, and you get a 10. All right, so from here, you can actually see that the formula used is E equals to AX plus B can be written as AEX plus B. Okay, all right, so which is appear in this formula in our notes. Okay, so in exam, you no need to write out so detailed because all these calculations are very simple. So I write it in a very detailed steps to let you see how we actually try to find the mean with linear function. All right. Okay, so this is something about the mean for a basic linear function here. So I hope that in the future, when you look at all these linear functions, you know how to find the mean already if the original mean is given EX. Okay, all right. Then now let's continue to the other. How about we talk? Let us talk about variance. All right. So variance, if let's say I give you given maybe variance X. Okay, so let's say I give you variance X is equals to, let's say, 3. Okay, so first, if they want you to calculate the value of variance, okay, so maybe I want you to find the variance 2. Okay, so what's the value for variance 2? It is always equals to 0. Okay, so first I want you to compare this with the E. E3, you get a 3. Variance number, you get a 0. So which means in short, right, if you have variance of any value, it will be equals to 0. All right, but of course, there are some formulas that we can prove at the end, okay, to show that the variance of a number equals to 0. Okay, but because the proving part, it is not so easy. So if you're interested, you can have a look. You can search online, have a look if you're interested. All right, but for us, we are not going to learn how to prove it, but we just learn how to apply it. Okay, how to apply all these concepts. Okay. All right, so variance A should be equal to 0. That means variance 3 equals to 0, variance 10 equals to 0, and so on. All right. Okay, then next. How about if let's say I want to find the variance, the value of variance, let's say 3x. Okay, so if I want to find out the variance 3x, the step will be something like this. You can take out the 3 from the variance, and then when you want to take out the 3 from the variance, you have to square the 3. So you become 3 square variance x, and after that you're having 3 square multiplied with 3, and then you're having 27. Okay, so again, I want you to make a simple comparison between the variance with the mean. So for the mean, when you want to take out the 3, right, you just take out straight away the 3. Okay, nothing special. Just take out the 3 and then you just multiply the EX with the 3. And then for the variance, it's a bit special because when you want to take out the 3 from the variance, after you take it up, you must square the value 3. So that means you take 3 squared times 3 equals to 27. So there's some differences between the E and also the variance. Alright, so please make sure that you take note on this part. Okay, and the formula for variance is shown here in our notes. Right, so this is the meaning of the formula. So we are having variance AX is equals to A square variance X. Alright, okay, then how about we continue and discuss another example for variance. If I want you to calculate the value for variance, okay, so let's say I want to calculate the value for variance, maybe 2x minus 1, let's say. Okay, so to calculate the value for variance 2x minus 1, generally what you need to do is I have to split it up. So you're having variance 2x plus variance 1. And after that, you take the 2 out from the variance, right? So you're having 2 square variance x plus 0. And if you continue further, you're having 4 variance x. So 4 variance x means that 4 times 3, and you get a 12. Okay, so again, if you look at the step here, and you compare it with the mean one, the formula will be slightly different also. Okay, because for the mean, when you're having 2x minus 5, and then here you have minus, you just follow the sign that you have. But for variance, the negative sign, when you want to expand it, it must be always positive. So this is another differences between it and also the variance. Alright, so there are 3, you have to compare like these 3. Okay, the differences between the mean and variance. And then when you want to calculate some harder example later, then you still use the same concept. Alright, okay, so remember when you're having the variance with negative sign, no matter how when you want to expand it, it must become positive. Because variance is always positive, right? They don't want you to have any chance to make it negative, therefore all the sign must be positive. Alright, so you should have 12, positive 12. Alright, so if you look at the values here, the equation here, it will be variance ax plus b equals to a squared plus variance x, because the variance b is 0. You see that variance 1 is 0. Alright, so therefore they didn't write it out. But if you look at the steps in detail, then generally this is what we have. Okay, so this concept and formula, please make sure that you know, and please take note on the differences between the mean and also the variance. Alright, so after that, for this whole chapter, you are going to apply all this. Okay, alright, so let's have a look for some example here. Let's say example 1. Okay, so for example 1, maybe I need to... Okay, so let's have a look for example 1. Okay, so let's say we are having the random variable x with this mean and also the variance 3. So from this sentence, you can write out the information given first. So that means you can write something like this. The EX is given, which is 10. And then the variance is given, which is 3. Okay, so first, they want you to find the mean and variance of the following random variable. So for first part, let's say they say W is equals to 5x plus 1. So 5x plus 1 is a linear function, right? When they want you to find the EW, how to find EW? It is E 5x plus 1. Therefore, you're having 5ex plus 1. Okay, so 5ex plus 1 means that you're having 5 times 10, which is 50. Okay, so in exam, you just need to write out the short steps only. You don't need to write also detail like what I showed you just now. So what the step that I showed you just now is to let you understand how we actually do all this kind of all these questions. Yeah. All right. So we are having EW equals to 50. Okay. Then how about if they want you to find the variance of W? So to find the variance of W, it will be equals to variance and then 5x plus 1. So if you expand everything, you have 5 square variance x plus variance 1. So variance 1 is a 0. I didn't write it out. Therefore, you're having 5 squared times 3, and you are having 75 as the variance. Okay, so I hope that you understand this. Okay, so if no problem, then the rest of the part I would like you to try on your own. Very, very simple, part B and part C. Okay, sorry, part B and also part 2. For part B, the answer for mean, the mean for V should be negative 14, and also the variance of V should be 12. And part B, the standard deviation should be 0.866. All right, so please make sure that you try and make sure that you understand how you get all the values here. Okay, by using the concept that I showed you just now. Okay, all right, so this is more of understanding part. Let's continue to the second example. Okay, so for the second example, all right, so they slightly, they try to put in some application here, all right. Okay, example 1, they give you the linear function like w equals to 5x plus 1. They already give it to you. Okay, for example number 2, they are not giving you the linear function straight away, but they want you to write out the linear function yourself. Okay, so you can have a look for the question here. Okay, so there are two types of degree, right? Degree in Fahrenheit and also degree in centigrade. Okay, so for Fahrenheit, you have mean 59 and also the variance 27. All right, so when you write it out, it should be something like this. Maybe I can put F as Fahrenheit, all right? Therefore, I'm having the mean of Fahrenheit is 59. And then the variance of Fahrenheit is 27. Okay, and after that, they want you to calculate the mean and variance for centigrade. Okay, so how to find out the mean and variance for centigrade? Okay, so here they tell you to convert degree Fahrenheit to centigrade. So that means to get the centigrade, what you need to do? Okay, you subtract 32 from Fahrenheit. So that means you're having Fahrenheit, you minus 32. And then after that, you multiply the whole thing with 5 over 9. Okay, so when you write it out, that means if you follow this equation, that means you can get a degree in centigrade already. All right, so this is how you write out the linear function yourself according to what the question described. All right. Okay, so after you have this already, they want you to calculate the mean of C and also the variance of C, right? Okay, so to calculate the mean of C, what is the step? Again, it is mean and then 5 over 9 and then F minus 32. Okay, so if you pull out the 5 over 9, it is still 5 over 9, right? And you're having EF. So what is EF? 59, then minus 32. And therefore, you should be able to get the answer 15. Again, you will see that I didn't write out my step in a very detailed way. So as long as you understand how to get the answer, then it should be okay. No need to write very, very detailed like what I did just now. Okay, after that, continue to variance. So if they want you to find the variance of C, okay, so variance of C means variance and then 5 over 9 F minus 32. Okay, so to show you in detail, I write it out in detail. Okay, so 5 over 9, when you take it up, what do you need to do? When you take it out from variance, you need to square it. And then you are having variance F plus variance 32. So variance 32 is a 0, therefore ignore it. Then you just need to take 25 divided by 81, multiply with variance of F. So what's the variance of F? It is given, which is 27. And after that, you should get 25 over 3. I think so far it's quite simple, right? Okay. And then this step in exam, no need to write, it's okay, this step. So I write out just to make sure that you understand how you actually get the answer. Okay, so in exam, no need to show until so detailed. Okay, you won't get any extra mark for this. All right, okay, then let's continue to example 3. Okay, so wait for a while, yeah. Okay, so the file is auto-saving and it is loading now. Okay, next we go to example 3. Okay, so for example 3, this is a partial question. And then let's have a look here. They tell you the exact mark have mean 70 and also the standard deviation 8.7. So usually for me, I would try to write all the information first. So mean X is 70 and then the variance X should be 8.7 squared. Right, because standard deviation is 8.7, therefore the variance should be 8.7 squared. Alright, so what is the 8.7 squared? You go and calculate the value here. Okay, then after that they say the marks need to be scaled using the formula y equals to ax plus b, so that the scale marks y have mean 55 and standard deviation 6.96. And they want you to find out the value for A and B. Okay, so now they give you another information where you're having EY, which is equals to 55, and also the variance of Y, which is equals to 6.96 squared. Okay, so the value you calculate yourself here. Okay, then actually this question, what they want you to find, they want you to find the A and B, the for A and also the value for B. Okay, so to find the value for A and B, right, again, you must use back the equation. Okay, so y is equals to what? Y equals to ax plus b. Okay, first equation that I can form is I want to find ey. So ey means what? Ey means e and then ax plus b. Okay, what is the value for ey? Ey is 55. Then you're having a. What is the value for ex? Ex is 70. Therefore, you will have 70a. What is the value for EB? You get a B. So this is the first equation. Okay, and then for the second equation that you can form is you are going to use the variance. So variance y equals to variance and then ax plus b. Alright, so what's the value for variance y? You should have 55. What is the value for variance ax? You pull out the a, become a squared, and then you multiply with the x, which is variance x is 8.7 squared. Oh, sorry, I did a mistake here. The variance y should be 6.96 squared. Okay, so this is the second equation. All right, so I think from the second equation, you can straight away get the A first. All right, so the second equation, you can straight away get the A first. And after that, for this part, substitute the value of A into equation number 1. Then only you get a B. So the B value should be -1. Okay, so I want you to have a try and see whether you can get an answer or not. A is 0.8, B is equals to -1. All right, and then for this question, some of the students, right, when they continue to solve the question, they might realize that they got two values for A, or you have to ignore one. Okay, so here, if you get the value A equals to -0.8, then we have to ignore it. Okay, why? So this is the reason. Because all the standard deviation or variance must be always positive. Okay, and then standard deviation for y is equals to a standard deviation for x. So if a is negative, then this one also have to be negative, which is not logic, which is not correct. Okay, because the standard deviation must be positive one, cannot be negative one. All right. Okay, so this is the reason, but a lot of students, they can't see it. All right, so I just write out here in case in your step you get the value A equals to -0.8, then please make sure that you ignore it. Okay, so we have only one value for the A, which is 0.8, and then B equals to -1. All right, okay, so this is what we have for our linear combination, the basic introduction. Okay, next video we are going to discuss slightly harder examples, like how are you going to combine two variables together, like combine x and y together, like 2x plus y, 3x minus y, and so on. Right?